So, today, let's talk about the regular expression matching problem. This problem is an interesting problem. Go through the description to see what it entails. But after we go to the description, we will notice that there are three patterns in which we need to be conscious of: the dots pattern, the alphabetical pattern, and then the asterisk pattern. Let's dive in a little bit to explain what each of these patterns will match correct for. For the dots pattern, this pattern will match any alphabetical character from A to Z. Going to the alphabetical pattern, this pattern will match any character that it represents. So in this case, if the pattern is an A, then it will match only A characters. If the pattern is a B, then it will match only B characters. But lastly, let's look at the asterisk pattern. This pattern always goes with a character before it. And it matches either zero or multiple occurrence of the characters that comes before it. So in this case, let's say we have P, then this pattern will only match either 0, 1, or multiple occurrence of P. So if we pass in an empty string, it will match correct. If we pass in a string of just a single P character, it will match correct. But if we pass in a string P, F, or any character apart from P, then this pattern will not match correct. But things get a little bit interesting when a dot is before the asterisk. In this case, any combination of character would actually match. If we use A, B, C, D as the input, it will actually match. Or any combination of characters. Now let's go to the meat of the problem where we pass in two inputs: the pattern string and the input string. Let's see how to solve it. In order to solve this, we go through two steps: the pattern formation step and recursive matching step. Let's go to the pattern formation step first. In the pattern formation step, we take in the pattern string and then loop through each of the character and merge any two characters that form a pattern. So in this case, we look through A. A is a single pattern. Then loop through B, then through asterisk, which would form a pattern with B. The same thing happens with A and asterisk, and also with C and asterisk. Then the last A forms a pattern as it stands alone. After this, we get the patterns array. Let's go to the next stage: the recursive matching stage. This is an interesting stage as we recursively check for the matching state. First, we get the patterns and transform them to a pattern nodes. To understand a pattern node, let's pick one and explore the process. We send in a string and initially pick the first character or pick no character, depending on the type of pattern in the node. For asterisk pattern, we initially pick no pattern, but for others we pick the first character. Then, we check if what we pick matches the pattern in the node. In this case, we pick A and the pattern is an A, we can see that they match. So that is a success. We also notice that the box at the upper edge transforms to green. This means that what was picked matches the pattern. After a match, we send the remainder of the string to the next node or empty space. If we send a string to an empty space like what we have now, what is returned is only true if the string is empty, otherwise false is returned. We can observe false returned when the box in the lower edge becomes red. It becomes green if true is returned. Since false is returned, we then add the next character to check for match again and send the remainder if it matches true. If not, we return a false. In our case, AC is tested and we see it is false. We then return false. This process happens in every node until each node return true or we return false. Let's return to our original case and see how it play out. We get out input string and pass it into the first pattern node. Now watch each node process the string.